Welcome to AV4-5. By the end of this lesson, you'll be able to calculate the volume of spheres and hemispheres. If you haven't done so already, take a moment to watch the visual proof of the formula that we're going to use today. This link is posted in Schoology. So when we're looking at the volume of a sphere, we can ask the question, how does the volume of a sphere compare to a cylinder with the same radius? So if you watch that visual proof, you can see that with our cylinder and our sphere, we can fit a whole cylinder, assuming the same radius, into that sphere, and then 1/3 more. So the volume of a sphere equals the volume of a cylinder plus another 1/3 volume of the cylinder. Let's remember that the volume of the cylinder was pi r squared h. And this h is actually also going to be the same thing as our radius. So let's think about where this comes from. Based on what we were just talking about in the last slide, we have pi r squared times h plus 1/3 pi r squared times h, but instead of our h's, let's remember that that's actually just the radius of the sphere. So here, if we look at this, and I say that this is 3 out of 3, or 1 whole, pi r cubed, r squared times r to the first is r cubed, plus 1/3 pi r cubed, because r squared times r is r cubed. When I add this, so 3 and 1 is 4, so 4/3 pi r cubed, that's where our volume formula comes from. So volume of a hemisphere, what's going to happen is that it's just going to be half the volume of a sphere. So the volume of a hemisphere equals half the volume of a sphere. 4/3 pi r cubed was the volume of a sphere, so half of that is 2/3 pi r cubed. So this is the volume of the hemisphere. Let's take a look at some examples. Here it says to find the volume of a sphere where each side of the cube measures 12 centimeters. So here this is 12 centimeters, 12 centimeters, or here's 12 centimeters. What this tells us then is that our radius of the sphere is 6 centimeters because it's half of that diameter of 12. So what we want to do is we want to make sure we start with our formula. Volume equals 4/3 pi r cubed. We're going to substitute our radius. So 4/3 pi, radius is 6, so 6 cubed. 6 cubed is 216, so I have 4/3 times 216 times pi. We're going to remember to use our strategies from good as gold to simplify. 3 goes into 216, 72 times. So now I have 4 times 72 times pi, which is 4 times 72 is 288. We're going to leave it in terms of pi. We're going to leave it exact unless you're told to use 3.14 or an approximation. All right, example number 2 says to find the volume of the plastic bowl. And what it's asking for is actually like how much plastic. It's not actually asking how much can we fit inside the bowl. It really wants to know how much plastic there is. So let's take some of this information and add it to our picture. The outer diameter is 6, which would mean that the outer radius is 3. The inner diameter is 4, so that would mean that the radius on that would be 2. So this whole thing would be 3, whereas from here to here would be 2. That's what it's talking about. What we're going to do to figure out how much plastic we have is we're going to take the bigger hemisphere, subtract the smaller hemisphere. Okay, so we're going to take 2/3 pi times our radius cubed of the bigger hemisphere, take away 2/3 pi r cubed from the smaller hemisphere. So now let's substitute in what we know. We have 2/3 pi. Radius of the outer one is 3, so 3 cubed, minus 2/3 pi. Radius of the smaller one is 2, so 2 cubed. Now we just need to do some math. So 3 cubed is 27. So I have 2/3 times 27 times pi minus 2/3, 2 cubed is 8 times pi. We can simplify 27 and 3 using that good as gold idea, where we get 1 and 9. So 2 times 9 is 18 pi minus 16/3 pi. Now we can actually take 16 minus 16/3, and you can remember how to subtract fractions, or if you put it into your calculator as 18 minus and then parentheses 6 divided by 3, you'll see that it's 12.6 repeating, which is the same thing as 12 and 2/3 pi. Now let's just remember here in this problem what we did is we took the volume of the big hemisphere and subtracted the volume of the small hemisphere. That gave us the plastic. Example number 3 says to find the volume of the figure. So I want the volume of the entire figure here. We do not just have one formula for this. We're going to actually have to use more than one. So if I see I have this hemisphere and this hemisphere, which creates a sphere. So we're going to find the volume of the sphere. And then we're going to add the volume of our cylinder here. And that will give us the volume of this whole composite figure. So the volume of the sphere, we have 4/3 pi r cubed. Let's go ahead and substitute what we know about the sphere. So we have 4/3 pi. My radius is 3, so 3 cubed. We have 4/3, 3 cubed. 3 times 3 times 3 is 27 times pi. I can simplify 3 and 27. They both can be divided by 3. So now I have 4 times 9, which is 36 pi. That's the volume of just the sphere. Now let's look at our cylinder. So for our cylinder, our formula is pi r squared times the height. We have pi, our radius of the cylinder is 3, so 3 squared. The height of our cylinder is 6. So we're going to do 3 squared, which is 9, times 6 times pi. 9 times 6 is 54 pi. And now I need to add these two together. 36 pi plus 54 pi is 90 pi. Again, we have what's called a composite figure. It's not just using one of our formulas. We actually are going to put more than one figure together. So here I can see that I have a hemisphere. So we're going to find the volume of the hemisphere. And that is, the formula is 2/3 pi r cubed. And I also see here that I have a cone. So we're going to add the volume of a cone. Let's start with our hemisphere. We have 2/3. The radius is 3, so 3 cubed times pi. 2/3 times 3 cubed is 27 times pi. We know that 3 and 27 can be divided by 3. 2 times 9 is 18, so I have 18 pi for the volume of the hemisphere. Now I need to find the volume of the cone. The formula for volume of a cone is 1/3 pi r squared h. So we have 1/3 pi. My radius is still 3. 3 squared, the height of the cone is 10. So I have 1/3 pi. 3 squared is 9 times 10. 9 times 10 is 90, so I have 1/3 times 90 times pi. I can simplify 3 and 90. They can both be divided by 3. So I have 30 pi left over. And now I need to add these together. 18 pi plus 30 pi is 48 pi. Example number 5 says find the radius of the sphere, given that the volume is 500 pi over 3. So let's of course start with our formula. For a sphere, our volume equals 4/3 pi r cubed. We know the volume, so I'm going to substitute the volume in. 500 pi over 3 equals 4/3 pi r cubed. And I want to find the radius here. What I'm going to do first is I am going to clear the denominators. So if I multiply both sides by 3, it clears my denominators. Here, 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 and here. So I don't have to deal with those fractions. So I have 500 pi equals 4 pi r cubed. Now I can divide both sides by 4 pi. 500 divided by 4 is 125. Pi divided by pi cancels, so I have 125 equals r cubed. I now need to cube root both sides. And I get 5 equals r. If you need a reminder as to how to put cube root into your calculator, remember in your graphing calculator, if you hit the word math, and then choose option 4, which looks like this. Then you hit enter, and it'll allow you to enter in 125, and it'll give you an answer of 5.